In this lesson, we are going to look at some percent problems, which are a little different from the percent problems that we have seen so far. Our first problem asks us to find what percent of 20 is 15. The wording of this problem is different and a little bit odd, but really it's simply just asking you to find a percent of 20, which would give you an answer of 15. So we can write what percent, we're going to use P for our unknown percent, and remember that percent is always over 100. So we don't know the percent, so P is going to be our variable or our unknown. So percent times 20 equals 15. So it's set up similarly to our other percent problems where we do percent times the number equals our answer. In this case, we don't know the percent, and that's why we have a P here for our variable. So our next job, in order to find what P is to solve this equation for P. So what I'm going to do here is I'm going to think of my 20 as 20 over 1. And then I'm going to put my P times 20 up here in the numerator. So I have P times 20. And in the denominator, I simply have 100 times 1, or 100. And I set that equal to 15. And then my goal is to get this P variable here all alone by itself on this side of the equal sign. Right now I have two things in the way of doing that. I have P divided by 100, so this 100 I need to move over, and I have P times 20, so this 20 I need to move over and leave P all alone by itself on this side of the equal sign. So I'm going to start by multiplying times 100. I can ask myself, how is this 100 attached to my variable? Right now it's attached here by division, and so I do the opposite operation in order to get rid of it, and I multiply. Well, whatever I do to one side of my equation, I must do to the other. So over here I need to also multiply this side by 100. So at this point, I now can cancel out these two 100s. 100 divided by 100 just equals 1. And so I can leave this as P times 20. And on this side, I have 15 times 100. Well, I still have one number here in the way of having this variable P all alone by itself on this side of the equal sign. I look at the 20 and ask myself how it's attached to the P, and it's by multiplication. And so I do the opposite operation, which is division, and I divide by 20. So I take this side and divide by 20. Whatever I do to one side of an equation, I always have to do to the other. So I need to divide this side by 20 as well. Now I have reached my goal of having the P all alone by itself on this side of the equal sign. My 20 divided by 20 is simply equal to 1 and can be canceled out. So I now have P equals 15 times 100 divided by 20. Plug that in and you will get 75. And so I can see here that my answer is 75. Now I don't want to just leave it as the number 75 because I'm looking at a percent. So I need to make sure and write my answer as 75%. The P equals 75, which would go right back in here, 75 divided by 100. But when I write my answer, I want to make sure that I have my percent symbol afterwards so that I know that this is representing 75% in answer to my question, what percent of 20 is 15? So we have found that 75% of 20 equals 15. Let's look at an application of this type of percentage problem. Sarah bought a toy for $10 and sold it at a markup of $6. So she sold the toy for $16. What percent is the markup on the sale of the toy? So we want to calculate the increase in price as a percentage of the original price of $10. So our percentage calculation is going to look like this. We want to know what percent, so what P over 100, would we multiply by $10 to get the markup of $6. And so we're now going to work on solving for P and finding out what P is that will tell us what percent of $10 equals $6. So again, like our last problem, I have P over 100, and then I can think of this as times 10 over 1 equals 6. So we'll work on it like this without our dollar signs, and then we'll find our percent as our answer. So I start out here by, in my numerator, doing P times 10 in the numerator, and my denominator is simply 100 times 1, which equals 100. And I still set this equal to 6. And just like we did before, we want this P all alone by itself on this side of the equal sign. Right now, there's a 10 in the way that's attached by multiplication, and there's a 100 in our way that's attached by division. So we need to multiply both sides by 100 in order to get rid of this 100 on this side. So over here I multiply by 100, and over here I multiply by 100, and I'm going to do this now in one step. So I've got my 100s canceled out. 100 divided by 100 equals 1. And then also I need to look at my 10 here. The 10 is attached to the P by multiplication, and so the opposite of multiplication is division, and I need to divide both sides by 10. So I'll put my divided by 10 over here, and on this side I can simply put a divided by 10 right here. So now this cancels out with this, my 10 and 10, and my 100 and 100. And I've reached the goal of finding P, or getting P, solving for P, getting it all alone by itself on this side of the equal sign. So now I simply have P equals here, and I do my calculations here. 6 times 100 is 600, divided by 10 equals 60. And so P equals 60. Now the answer to my question, though, needs to be in percent. What percent is the markup on the sale of the toy? So I could go back up here in this P here, and I could put my answer. I found the answer for P to be 60. But remember that when you report your answer, you need to report it in percent. And so 60 over 100 is 60%. So I'll report my answer as 60%. And so Sarah has increased or marked up the price of the toy by 60% of its original price of $10. Let's look at another type of percent problem. Our problem here asks us 60 is 10% of what number? So here in this type of problem, we have to find the original number. If you find 10% of this original unknown number, you would get 60 as an answer. So let's write our percent calculation using the similar formulas to what we've been using already for our percent problems. So we have 10%, so we know 10% we write as 10 divided by 100, or 10 over 100, 10% of some number. We don't know the number, it's our unknown number. This time we'll use n as our variable for this unknown number that we are trying to find. We know that 10% of this number equals 60. So we set it up similarly to how we've been doing these percent problems, but now our job is to solve for n. And we're going to do the same kind of multiplications and divisions to both sides of our equal sign in order to get n all alone by itself on this left-hand side of the equal sign. So let's rearrange this a little bit by looking at our numerators. And I can think of, remember, any number, any whole number I can put over 1 if it helps you to see it as a fraction when we're working with fractions. So I'll place my unknown number n over 1, and that will help me to set it up to solve it. So in my numerator I have 10 times n, and in the denominator on this side I have 100 times 1, which of course is simply 100. Then I have my equal sign and 60 over here on the right hand side. So I look at the n and I see that a 10 is attached to the n by multiplication and a 100 is attached to the n by division. So I need to do the opposite operations in order to move those and get rid of those, cancel them out, and move them to the other side so that n is alone. So first I'll start by multiplying by 100 on this side and multiplying by 100 on this side. Whatever I do to one side of an equation, I have to do to the other in order to maintain balance. So I can now cancel out my 100s. 100 divided by 100 equals 1. I can cancel that out. And now I have the n here still with a 10 attached. The 10 is attached to the n by multiplication. And so I use the opposite operation, which is division, and I divide by 10 in order to cancel this out. Well, whatever I do to one side of an equation, I have to do to the other. So I don't want to forget to come over here and divide the right-hand side by 10. Now I've reached my goal of getting this n all alone by itself on this side of the equal sign. So I now have n equals, and I perform my calculation. 60 times 100 divided by 10 equals 600. And so the answer to this unknown number is 600. 60 is 10% of what number? 60 is 10% of 600. Let's take a look at an application of this type of percentage problem. Sarah paid $10 sales tax for her watch. If the sales tax is 5% of the sale price, what was the cost of the watch? So basically this is asking us 10 is 5% of what number? Using what we've just learned, let's write the percentage calculation. So we would take our 5%, put 5 over 100, times this unknown number n. We don't know the cost of the watch yet, but we do know that 5% of it equals $10. So we now simply need to solve this problem for n, just like we did in our other problems. So I'm going to place n over 1, and in my numerator I have 5 times n. In the denominator I have 100. And then I have 10 still on this side of the equal sign. I multiply both sides by 100 in order to cancel this 100, and I divide both sides by 5 in order to cancel this 5. So now I have solved this equation for n, and I have n all alone by itself on this side of the equal sign. Once I perform my calculation of 10 times 100 divided by 5, I find that n equals 200. Now, we want to make sure we're reporting our answer correctly, and we look up here and see that since we're looking at the cost of a watch, we need to make sure and report our answer in dollars. So Sarah paid $10 sales tax for her watch. If the sales tax is 5% of the sale price, what was the cost of the watch? We found that the watch cost $200. 5% of $200 equals $10. There are many more applications of percentages. This lesson just gives you a glimpse into how important percentage is in real life.